presentation, I'm going to focus mainly on my work with my company, my startup, Encerus. And our sole focus really is to provide artificial intelligence tools to assist operators in better operating their plant and to optimize treatment around high expenditure items such as energy and chemical consumption, which also have a direct impact on the carbon footprint of the facility. And so that's going to be the focus of today's talk. But I have a lot of experience as a process engineer, designing, building, and commissioning wastewater treatment facilities. And I actually have another company with my family that's doing just that for both Encerus and my other company, Circle H2O, which I won't focus on for today's talk too much. We're working on projects in India, so I'm excited to be able to get more feedback from the Indian community about what more we could be doing. So this is probably everyone in this call is vastly familiar with the fact that we're having a water crisis, and that's only going to get worse in our lifetimes before it gets better. Quality is degrading, and I think even more concerning is the quantity is decreasing actually in the light of climate change, and our populations are increasing. So we've seen through the arc of history that as we've stressed our water resources more, we've had to do more to treat that water. Before Mother Nature would take care of it and we wouldn't have to do anything. Then we finally had urban city centers and we thought, let's take this wastewater out of the urban city centers, but we weren't doing much to treat it. Now, I think the status quo is let's treat to discharge, but more and more that status quo is changing, especially I think India is leading the way where we have to treat to recycle and reuse. We have to treat to recover the energy in that wastewater. We have to treat to recover nutrients in that wastewater. So wastewater resource recovery is the new norm. In fact, we're now calling these facilities WRRFs, wastewater resource recovery facilities, instead of WTPs, wastewater treatment plants. And the whole shift in mindset has already started with a big momentum. But as we do more and recover more from our wastewater, that's leading to more complex and advanced treatment solutions, especially when you look at treatment at a centralized scale. And these advanced treatment systems, not only are they more complex in operations, but they also have more operational expenditures, especially energy and chemical consumption. And energy in a lot of places in India is twice or thrice what I pay in Champagne. And so I think that we are seeing that there's a need for reusing wastewater. It's in fact the cheapest source of resource for water reuse. It's much cheaper to recycle wastewater than do desalination. It definitely makes a lot of sense, but it does come with more complex treatment systems. And so, as we move to more advanced treatment systems, we really need to equip the operators with the tools they need to better operate these facilities. I think a lot of times operators may have not operated a facility like this and may have had limited training before they get into the role of head operator. So how can we sort of digitize our tools for operators to really assist them as they operate these facilities and sort of make up for maybe training gaps that might be taking place at the wastewater treatment facilities. I think that one of the things I've noticed is, one of the things I've noticed in my career, I've done quite a few projects in India as well, is that just because the facility and infrastructure is there doesn't mean that it's actually treating the water to the desired outcome. And oftentimes it has to do with operation of the facility. So I feel really excited to be working on a few facilities, and I make sure that I have weekly calls with the plant operators so I can really develop tools that will empower them to better make decisions. And this enabling of digital tools is pretty recent. we weren't able to do as much as we can today for as cost effectively as we can today. So the water and wastewater industry, like many other industries in our world today, is undergoing a digital transformation, drawing on new technologies and connectivity, mobility, automation, and data analytics. And artificial tools can be used to assist operators and optimize plant operations in ways that were previously impossible or cost prohibitive. So our solution offering is what we call the Answers Artificial Intelligence Wastewater Stack, and it consists of 3 layers. The bottom layer is the data itself. That sets the foundation for anything we do. And so, that may be coming from physical sensors. You mentioned IoT meters. It could be coming from the IoT meters. And to be quite honest, it often comes from other sources as well, like daily operator logs, for example. And so we have, it can even come from open source data sources like weather, for example. So we have the bottom layer, which is the layer of data. And we can, we oftentimes get into the plant and actually build out the the sensors for the wastewater treatment facility and the automation system. And it's all, ready to go into the digital platform that we have. Or a facility may already have, PLC, HMI in place and all the relevant information that they need to automate the facility and manage the facility. So then we would just come in on top of that and bring in that data into our data pipeline. The core of what we do is advanced analytics, so using artificial intelligence and machine learning to provide insights to our operators and clients. So that is all happening in the cloud. We bring all the data into a cloud database, and then we run our training and run our algorithms on that data. And then, this is all happening in near real time. So depending on the client, it could be every 5 minutes, it could be 10 minutes, but it's happening in pretty much near real time. And the insights themselves are also going back to the client through a dashboard insights delivery platform, where we provide some useful visualizations, but also some useful actionable insights to the operators. So our AI wastewater stack, it helps plant operators make real-time data-driven decisions and determine the optimal operational set points at the plant to meet treated water quality standards while reducing energy and chemical consumption. And this is just a snapshot of part of one of our dashboards, but we're really in this, this project's a membrane bioreactor project where they're recycling and reusing sewage wastewater. So we have, in that case, these membranes that need weekly or monthly chemical cleaning, and they also need air scouring to keep them from fouling. So we've developed a algorithm to monitor permeability and treated water quality in order to optimize the chemical usage and the air scouring rates that this facility should be deploying on a daily basis to optimize that part of the process, as an example of something that we've done for a client. So, in terms of, we've worked on several projects. We have, one deployment of this AI wastewater stack in India right now, and more scheduled to come online. But we've also done a lot of projects in the US, especially demonstration projects. And I've sort of summarized some of the things that we've worked on. So one thing that we're working on is guidance to operators. And this could be something as just how much sludge you should waste on a daily basis. But I'm finding from interactions with operators at these wastewater facilities that, they're happy to have insights delivered to them like this, like, well, today, should I be wasting more sludge or less sludge? Or, when is my next maintenance for a particular piece of equipment? And is there anything abnormal happening in that particular piece of equipment based on current temperature data that we might be getting? I already mentioned chemical and energy intensive processes, optimizing those at the wastewater treatment plants. We've also worked on a project where we estimate difficult to measure parameters in real time using a soft sensor approach. And that was for the US Army, where we basically took real-time data from low-cost sensors, and we translated that into whether that water was safe to discharge or safe to reuse. And that didn't involve any laboratory analysis, because a lot of the facilities that the US Army was interested in wouldn't have the luxury of having a lab doing daily testing. So we developed a classification algorithm for them based on certain low-cost sensors to be able to determine if that water was safe to reuse or safe to discharge. Predict events of concerns like violation or equipment downtime so that early corrective action can be taken. So these are the types of problems we've worked on, and the entire stack involves bringing this data from sensors, actuators, but also, like I said, operator logbooks, open source data into one common database that's located in the cloud for us to then do analytics and real-time reporting to our clients. And this is just kind of another schematic of where kind of the data sources could come from. They come from lab data, they come from SCADA, they come from the motor, health data, they come from weather, they can come from GIS. And, the kind of insights we would be providing span a range of things from optimal set points, predicted future values, estimated values, classifications, and daily actions. Our team is a small and focused team. I'm the founder and president of Ensurus, and I've been in the wastewater field for over 15 years. I started off as a process engineer, then I went on to do project management, where I actually was involved in the entire project life cycle of a turnkey project, from engineering design to procurement to logistics to being on site during the construction and commissioning. And during my time commissioning plants, worked extensively with automation systems, and I continue to do so today, which is kind of what planted the seed in my head for this company, that our automation systems are just sort of sitting there automating our facilities. Well, why don't we use that data for something of higher value in addition to the automation? And then my chief scientist, Professor Love Varshney, he's an associate professor at the University of Illinois at Urbana-Champaign in the electrical and computer engineering department, and his expertise is artificial intelligence, data science, sensor networks, and cloud computing, innovation, and engineering entrepreneurship. And we really do use the cutting edge in the field. With Professor Varshney being on the team, we're making sure that we're really pushing the bounds of what's being done. And in fact, we do a lot of R&D work as well to keep our systems at the cutting edge of what's available in terms of analytical approaches. And that pretty much is my talk, and I'm happy to take the discussion forward or answer any questions that anyone has. Thank you.